In this problem, we have an aircraft carrier that's traveling forward at 60 kilometers per hour. At the instant shown, plane A has just taken off the end of the carrier and is traveling forward at 250 kilometers per hour, measured from still water. If plane B is traveling along a different runway of the carrier in the direction shown at 200 kilometers per hour with respect to the carrier deck, determine the velocity of plane A as seen by the pilot of plane B. All right, so this is a relative velocity equation problem. So we need to determine which of the values in the problem statement are absolute and which are relative. In this problem, it's pretty straightforward. Other problems, it may not be. So first, the carrier is traveling at 60 kilometers per hour. That's absolute. Plane A is traveling at 250 kilometers per hour measured from still water. That's absolute. But plane B is traveling at 200 kilometers per hour with respect to the carrier deck. So that's relative. All right, so the carrier is absolute, so we're going to label that V sub C. Plane A is absolute, V sub A. Plane B is relative, so VB relative to C. And what we want to solve for is the velocity of A relative to B. All right, so how do we start this problem? Well, like you start almost every problem, you draw a figure. And especially in relative velocity problems, you want to draw your velocities and have a coordinate system, because the relative velocity equation is a vector equation. All right, and we want to write all the velocities in vector form, because you can't use the equation unless they're in vector form, and then relate those velocities through the relative velocity equation. All right, so here's our figure looking at the top view. So we have the carrier, the velocity of the carrier, plane A, velocity of A, and then plane B, its relative velocity. And we have the coordinate system X and Y. All right, so VA and VC, they're both in the X direction. VB relative to C will have to decompose into the X and the Y. All right, so here we go. Here are the velocities in vector form. Once you have that, it's really easy. All you do is plug into the relative velocity equation and get the answer that you want. Now notice the form of the equation that I use. Velocity of B relative to C equals VB minus VC. I like this form because it's very easy to remember. B relative to C, B minus C. It's very easy to keep straight in your head. All right, so again, you just plug in the velocities and get out what you need.